All right, cool. 2.5 sum list. Okay, so let's save this guy. Chapter 2, problem 5, sum list.clj. Okay. And we've never done this before, but cool, still passes, yeah. But we need to change everything. Sum list. I guess I should really read the question at the very beginning. All right. You have two numbers represented by a linked list, where each node contains a single digit. Okay. The digits are stored in reverse order, such that the one digit is in the head. One digit is at the head of the list. Write a function that adds the two numbers and returns the sum as a linked list. You are not allowed to cheat, just convert the list into an integer. Okay. Okay, this ain't too bad. Or, I actually have. So, if we have an input of 716, and we are adding it to 592, we get that is 617. Okay. And that means we get an output of 2219, right? And that is 912. Right? Because 617 plus 295 equals 912. So you're basically just in reverse list sequence order adding up all this stuff, you know? Or no, actually not reversed. Yeah. It's the representation of the number is reversed, which makes doing this a little bit easier, right? Because you just have to do it in order, right? So that is some list, yeah, technically with an S at the end of it. All right, and so N1 and N2, I guess we can call these things, and let's put in this example first of all, right? And so it's probably enough example, actually. Well, so if we add the empty list to the empty list, we should get the empty list, I guess. I don't know. I don't know what we should do in that case, really. You know. I think that yeah, if you add the empty list to the empty list, you should get the empty list, kind of. But I could also see the argument being made that if you add the empty list to the empty list, you should get the list containing the value 0. So since that wasn't really specified, I think it makes the most sense that if either of these two arguments are the empty list, or are the list of all zeros for that matter, right? Then it should return the other one, right? But if they're both the empty list, yeah, I don't know, honestly. You know, so there's another interesting. Yeah, I think it should return the empty list. I'm just going to go with it. I mean, it's no mathematical rigor here, but what about if you do this then, though? What should this return? Should this return 0? According to the rules I just made, I don't know. I think you should collapse the zeros out, or you should filter out the zeros if you have zeros in your results. But that's only on the leading side, right? I don't know. Yeah, what should happen if you pass in the empty list? I think we should convert the empty list into a list with 1 0 in it. No, I don't. I changed my mind. I think I think the way we're going to think about it is this is the initial number, and this is the thing you're adding to it, right? So I'm going to take whatever you do here, and I'm going to pad. I guess I have to pad both sides, don't I? Potentially. I mean, let's just go through a lot of them because I feel like there's a lot of corner cases in this problem that make it kind of complicated. How about 5 and let's just say 5, right? That should return 0, 1, right? 10, right? Okay, that's fine. How about 55 and 5? That should return 0, 6. Let's say 55 and 7. It's 6, 2, right? How about this actual example? 7, 7, 1, 6. Oops, that's the result. Yeah. 2, 1, 9 should be the result of 7, 1, 6 and 5, 9, 2. Okay, cool. But what about weird ones where you have different sized? I mean, this is an example of different size, but I feel like we may just be filtering out zeros if that's all you got. So what about like 1, 2, 3, 4, 5? But I am. Oops, that's not even right. Oh, you know what? I'd rather do it that way. Nah, I'm just gonna. I could have entered them as real numbers and had this little function right here convert them into reverse list, but let's just do it this way. So 5, 4, 3, 2, 1 should be built out of 0, 0, 0, 3, 2, 1. That's 1,200. Right. 12,300 is what that is. Plus 45, right? So 54, right? I'm just going to reverse that as well, just to make sure that it works in both directions. All right, so that's, I think, a number of cases. That's pretty decent. So sum the list of N1 and N2. Let's think about it. All right. So first of all, we're going to have to decide that 1 is the one that is... I need the two lists to be equivalently large, right? That makes it easier for me to reason about. And I need to pad zeros onto the right. Right? Okay, so let's take N1 and N2, right? What did I just do? All right, here we go. And we're going to map over them. And what is the function we're going to take on? We're going to take the count. Ooh, that's my list. We're going to take the count, right? And so now we know which one is bigger, right? Do we really need to know which one's bigger? I mean, it does not freaking matter because we're already going to have to linearly walk across the entire list. So it doesn't matter how many times we read across this entire list, as long as it's less than n squared, basically. As long as it's constant, really. But so I'm not going to worry about stuff like that. But so this is C1 and C2, right? We got the two counts, right, of N1 and N2. And I'm just going to take the C3, which is just going to be the max of C1 and C2, right? So now I know the size of the bigger one, right? And I don't care which one's the bigger one, but I need to make them both the same size. And I need to add zeros onto the end of the smaller one. So let's just redefine N1 and N2 as being the map of the cat. Is this right? What am I doing wrong here? There's something's weird about this. No, okay. The cat of whichever one's coming in plus the cycle of 0, right? So infinite list of 0. Let's check that's what cycle does. Is it repeat? Maybe is what I mean. I think I mean repeat. Return a lazy infinite sequence of actually, we could actually specify a thing, but then I got to do the math and everything. That's complicated. So we're gonna build a list, an infinite list for both of them of of their original list plus infinite zeros on the end of them, right? And then, and we're using repeat, not cycle. And then we're going to take C3, cool, C3, and so now we have two. Now N1 and N2 have been redefined, which I rarely do, but in this case, I don't want to even think. I want them to have been passed in well, basically, right? And so I'm passing them in this way, right? I'm literally making it impossible for you to access their original values anymore. Maybe it's a good idea, maybe it's not. And so now, now I can just do step order math on them, right? But we still have some issues in that I feel like we need the carry bit, right? So we have the N1 integer, right? 0 through 9. We have the N2 integer, 0 through 9. We also have the carry bit from the previous guy, which is 0 or 1, right? Yep. Okay. Alright, so 0, 1. So I mean one thing to do would be to build a thing for both of them. I don't know. Maybe we don't want to redefine N1 2. Maybe we want to redefine. Whoops, that's too far. I don't know. MS, right? Which is just. Oh, we never actually took the map of anything, did we? Which is just going to be N1 and N2, right? Am I at the right place? No, I'm not. Should be here. Okay, so we have MS, which is going to be equivalent to the length of the larger of the two, N1 or N2, right? And it's, I feel like that's a lie. Yeah, no, this is N1 and N2. I'm going to call them N3 and N4, just to stop myself from doing that. I have people I work with who get angry when I do stuff like that, so I won't. But N3 and N4, right? And then what we actually want to do is just map over. We're going to build a new map sequence called the map of. One thing we're mapping over is N3 and N4, and it's going to be the vector. But we also want to get the carry bit, right? So I'm going to put in another infinite 0 in there, right? So we got three things. The carry bit, we got a vector of the carry bit, the N1 value, and the N2 value, right? Is our new. It's not really a map, is it? It's a vector. Okay. this is lost meaning. So let's give it a name now. Digits. Sure. Alright, so now we got the digits, but we need to sort of add together. The carry bit's a bit complicated because it comes from the previous one, right? How can we do that easily? Maybe this wasn't the right one to do that, actually. I feel like something was jumped here. I mean, could just do a loop recur. I'm not crazy about using loop recur. Could just do a for. No, because we need to pass the. We need to sort of jump values across. I need to process a sequence where the carry bit is the result of whether the sum of the previous sequence was greater than 12. So I'm going to do them one at a time. Yeah. So forget this. What I am going to do is pass in like A and B, right? And we're going to do this feels weird. Something feels weird about this. I can't put my finger on it, but A and B, the result of these two things should just be a summation, right? That's just plus, really. We're going to add in each A and B. The problem is, now we might end up with, like, if we have 7 and 5, we'll end up with 12, right? Which isn't a valid single digit, you know? But that's okay. We have digits now. And, okay, I guess what we can do is then partition digits, right, in some way. For instance, like maybe... partition, closure core digits. So I got in, which is, I forget, but then we got our step size, which we want to set to 1, right? And okay, so I think we just want 2. Partition 2 digits. Wait, is that right? Yeah, so we're just going to grab the next 2 every single time. I always get confused about what happens about the beginning and the end when you do stuff like this stuff, so we'll see what happens. I feel like maybe let's just return that and see what we got. You know, we got a whole lot of examples in here, though, so maybe let's just focus on the one that is the one for whom we know should work. Oh, wait, was that the one? No, did I make this up? None of these are... none of these are the right ones, are they? Okay. Wait, did I make these up? Yeah, no, I made these up, yeah. Oh, this is the one that we know should work, right? Yeah. Okay. And so let's just see what we got. Chapter 2, problem 9. That doesn't seem right, does it? Chapter 1, problem 9. Why is it still saying this? Oh, because that's the problem I opened last. Okay. Problem 5. Is that right? I think maybe it's not. We've been saving it to the wrong location. Oh, no, it is some list. Okay. All right. Damn, we still got 3 more problems to do. And I put little stars next to it, which means when I read them through, I thought they were all kind of hard. Okay, well, whatever. So, let's see what we got. So blah, blah. doesn't make sense because we actually have two arguments. No, we only have one. Testing Java-lang class Java-lang persistent vector cannot be cast to Java-lang number. What we're trying to do is positive. That's probably under partition. Okay, so if partition's failing, let's just get digits and see what we got. If digits is failing, let's just get... Wait, it feels like partition is still failing. I haven't called partition anymore. Oh. Whoops. I don't know why I started calling this. Alright, well, that may have been the issue there, so let's just give that a shot again. Okay. So we got something, right? I didn't expect it to work, but... that's pretty... It's not working very well, honestly, at all, but... we expected 912, and instead we got this list with 12 and 10 inside it, so that's wonderful. Okay. First of all, I think we're processing these in... So I see the first one worked, right? 7 plus 5 is 12. Okay, cool. I think this is one of the issues with partition, right? Is it always cuts you short because you're taking 2. Oh, but you know what? I think there is an option for this in partition, too. Yeah, we can put a padding in here, which is... We're just going to put 0 in there. But that does mean we need to specify the step. But I think the step is... Oh, it defaults to in. Okay, so we actually want to make the step 2 as well, then I think... No, we want to make the step 1. Well, hell, let's figure it out. I know. And then we want to pad it with zeros. Failure. I don't know why I did that twice, expecting a different result. So 617 plus 295 equaled 912 is what we're hoping for. But we're getting some weird stuff here. I don't know where it's going wrong precisely. Without reading a whole lot, which I'm not fond of. Let's just do digits, see if we can get that far. Alright. So we got 12, 10, and 8. So I'm seeing 7 plus 5 is 12. Okay, that seems reasonable. 1 plus 9 is 10. That seems reasonable. And 8 plus, or 6 plus 2 is 8. That seems reasonable. Furthermore, if you took the 12 and took off the 10 part of the 12 and added it to this one, you get 11 here instead of 10, right? And then that matches that 1 right here, right? So the 2 matches the 2 here. The 11 matches the 1 here. If you took the 10 from the 11, so you left 1, you get 8 plus 1. Yeah, so it's I think it's working the way we want it to work. The partition, something with the partition isn't working the way it is supposed to work, or that I understand it works, but... okay, returns will list a sequence of list of in items each. Okay. At offset step apart. Okay. If step is not supplied, defaults to in. And if you do that, you're literally just splitting it into things of size n. But if you do less than n, or if you do 1, what do I do? Okay. If a pad collection is supplied, oh, collection. It's a collection that you pad at the end. Use its elements as necessary to complete last partition up to n items. Oh, it's a collection. Okay, I think that's the issue. So I think we should only need one item in this collection. It should just be the empty zero, right? I wonder if what happens if you pass an infinite sequence as the collection. In cases there are not enough padding elements, return a partition. Yeah, we've seen that behavior. Okay, whoops. Where did I? Whoa, whoa. Alright, so let's see what happens now. Okay, that looks cool. 12 and 10, 10 and 8, 8 and 0. Okay, so that's backwards. That's not what I wanted. 12 and 10. You get, oh, fudge. Everything's, I want it the other way around. Don't I? Right? Fudge. I want the previous one, not the partition of the next one. What am I doing that's silly here? I could just reverse it and then take the partition. Why do I have to do that? I don't quite get it. How do I have a trailing partition, so to speak? What if I just pop another value into the front? Maybe that's what I want to do. I kind of feel like that may make more sense. So I'm going to try something. I'm going to try popping. Wait, where was I? I was here. Yeah. So rather than doing this at all, we're going to do that, but I'm going to just cons drop, right? Or let's just call it ignored. Okay, that looks pretty good. So I'm saying you take the mod base 10 off of this, right? And that's what you put in here. You take the mod base 10 off of this, and you know, I should just make it 0. That's a silly thing to put in there. I'm gonna put 0 at the front, right? Because obviously in the first digit you can't have a carry because you're the first digit, right? Okay, yeah, you take it. You, for every single one of these, basically, you take the mod of this as the actual value, plus if this is greater than or equal to 10, then add that in as well. What's the three things? There's mod, there's remainder, there's, what's the third thing? It's like quotient, right? So it's actually, I think the quotient of this plus the mod of that should be the result, right? Let's see if that works. Let's see what happens. Okay. So, I don't know. Yeah, I'm running out of names here, and they're kind of getting stupid. And then I'm going to just map across something, but it's going to be on the back of digits, right? What we're going to do is we're going to take the addition of the quote of u base 10 plus the remainder. Oh crap, I forget what the difference between these two things is all the time. Well, that's the difference between a remainder and a mod. Remainder of dividing numerator by denominator. It seems like what I want. Remainder and mod are commonly used to get the remainder. Mod means newths, I assume they mean mod, truncating towards negativity. Remainder implements ANSI C's modulo, I think, operator. Alright, percent. Absolute values stay the same, always the distance towards 0. I do not think this helps a whole lot, but okay, let's answer some examples. Remainder of negative 10, 3 is negative 1. Okay, so at minimum, one thing is remainder can return a positive or a negative number. Well, maybe mod can't. Let's just read through that. So if there's anything surprising here, mod 10 negative 3 returns 1. So it's almost like this one's saying, how many of these can I take out? And what am I left with at the point that I've taken out all the ones I can take out? So negative 10, I can take out 3. Now I have negative 7. Take out 3, negative 4. Take out 3, and I have negative 1. Now I can't take out 3 again. Why not, actually? Because negative 1 is less than 3. Although if I... Alright, yeah. Similarly here, I can take out 3. I can take out negative 3. Or I can apply... I can effectively add... Yeah, I think it's a remainder is effectively how many of these can I add into this before the absolute value of what I have left is less than this. Okay, so 10, negative 3. I add negative 3, 7. I add negative 3, 4. Negative 3, 1. Okay. Negative 10, negative 3. How many of these can I add? Oh, hell, I just don't get it. Anyway, we want... It doesn't really... Well, no, it does matter. Well, we can't do negative numbers because we didn't specify that. Yeah, I do not really get what to do. I'd have to think about it to really get this, and I don't feel like it. Okay, so, anyway, I think that might give us something. Let's see what we got. No good. Closure link legacy could not be cast a traveling number. Yeah, I get what you're saying, because this is no way a... So this is a vector digits. So that means you need to be a vector handler, not a just I accept a value. So your vector contains a j, I guess. I don't know. Oh, I didn't even finish that guy out, did I? Okay, remainder j of 10. Unsupported binding form plus quote I remainder j. What's wrong with that? Oh, is this a... Am I still in the... Yeah. Too many spaces here. Oh, never mind. Cool. Alright. Whoa. Okay. Let's try this. Cool. Alright, well, we didn't really define really what should happen in these cases. I'm actually pleased they didn't just crash. But you did end up returning 0. And that is because we put that 0 in there, isn't it? Cute. I don't know. I kind of feel like this is the right answer, right? What about this one? This one is something's wrong. 55 plus 7 should be 62. Instead it was 2. It feels like maybe people haven't padded themselves enough. Wait a minute, 55? That's not how you write that. Okay, now we're back to something slightly easier. And, I mean, it does, at this point, like, we can drop... We could take the... I mean, we could just reverse each... We could reverse the list that's being returned, dropped drop while zeros. Sure, why not? You know. Just keep going. Reverse the list. Drop while 0 on that list. Reverse again. Woo-wee. Okay. I do still have one failure. That's interesting. Zero, one, sum list of 5, 5. So we're getting 0. Is that where were we having a problem with this guy before? Yeah, we were. Okay. It's not something I just introduced. 5 and 5 is 10. 10 should be the remainder. Interesting. What is going on here? That is the remainder. Why would this one fail specifically? Well, when I have no idea, I just start printing things. Alright, print line. Sum list. Sum list. Alright, vec digits. And let's just focus on the one that's failing. Since everybody else is able to handle it. Jerk. Alright. 0 and 10. I think we're... Huh. But it doesn't go forward because there is no next one. Fascinating. That is interesting. Okay. Well, let's try putting that guy back in here. See if he'll pad this. I don't think this will help, actually. No, it did. Okay. 0 and 10, and 10 and 0. Huh, that's coolish. I didn't realize that. Yeah, we have to make space in the link list for the next guy, so to speak. Yeah, in the list. I don't really call them link list. But... Interesting. Okay. Cool. Let's get this print line out of here. All right, that seems good enough for government work. All right, so MGS stage. Copy our fantastic template. Commit. This is sum list. Problem 2.5.